Hey everyone, welcome back to the channel. Today, we're diving into one of the most mind-bending concepts in all of physics, quantum tunneling. You've probably heard whispers of it, maybe even seen it used in science fiction. But what is it really? Let's unravel this fascinating idea. Because quantum tunneling isn't just theory, it's a real, measurable effect that powers our universe. Even though walking through walls like in the movies is a massive leap from the microscopic world, we'll explore what actually happens at the quantum level, and then we'll tackle why macroscopic tunneling, like a person walking through a solid wall, is technically possible in theory. So, let's kick things off with what quantum tunneling actually is. In quantum mechanics, tiny particles like electrons, protons, or even whole atoms don't behave like miniature billiard balls. Instead, they're described by what we call wave functions. Think of a wave function as a probability distribution. It tells us where a particle is likely to be. Now, imagine one of these particles approaches an energy barrier, like an electric field or a potential wall. According to classical physics, if the particle doesn't have enough energy to climb over that wall, it simply stops, right? But quantum physics has a different story. It says that the particle's wave function can actually extend through the barrier. This means there's a small, but definite chance that the particle will suddenly appear on the other side, as if it magically tunneled through. It's not magic, though. It's probability physics in action. The particle isn't digging a hole or burrowing through in a classical sense. Instead, its wave-like nature allows a tiny bit of its existence probability to leak through the barrier. Due to the fundamental uncertainty at the quantum level, pretty wild, right? Now, you might think this sounds like some abstract theoretical quirk, but quantum tunneling is anything but hypothetical. It's absolutely essential to how our universe works. For instance, take nuclear fusion in the sun. Protons fuse together to create all that glorious sunshine. But they can only do this because they tunnel through their electrostatic repulsion. Without tunneling, the sun would need impossible temperatures to shine. Every star you see twinkling in the night sky owes its existence to quantum tunneling. Another crucial example is radioactive decay. Alpha particles escape atomic nuclei by tunneling through a nuclear potential barrier. Then there's the world of electronics. Devices like tunnel diodes and Josephson junctions rely on tunneling for ultra-fast switching. And the behavior of qubits in quantum computing, even the scanning tunneling microscope, or STM, uses tunneling to map surfaces at an atomic scale by detecting the tunneling current between a tiny tip and a sample. So, yes, tunneling is incredibly real and utterly vital to life and technology. The idea of passing through matter pops up in all sorts of spiritual, metaphysical, and paranormal traditions. Think levitation or dematerialization. Quantum tunneling, a genuine scientific process. Sounds like a scientific version of that, but it's super important to remember they operate on completely different scales and mechanisms. Quantum tunneling is about subatomic wave function behavior, while phasing or intangible states are generally metaphysical concepts, not physical ones. That said, physics is always exploring incredible possibilities, like quantum coherence and exotic matter. We already see large-scale quantum effects in things like superconductors and superfluids. Bose-Einstein condensates, for example, allow atoms to behave as a single quantum entity. These breakthroughs do open speculative doors to future technologies like quantum teleportation. So, to sum it all up, quantum tunneling is when a particle's wave function leaks through an energy bar. It's crucial for everything from nuclear fusion in stars to cutting-edge semiconductors and quantum computing. In short, quantum tunneling reveals that the universe isn't quite as solid as it seems. Everything has a wave aspect that can, sometimes, pass through barriers. It's a stunning testament to the bizarre and beautiful world of quantum mechanics. Thank you so much for joining me on this quantum journey. If you found this explanation helpful or just plain fascinating, please hit the like. And don't forget to subscribe for more deep dives into the wonders of our universe.